So guys, in the first part of this example, we calculated this is section 1, and then this is section 2. In this example, and this way to do this example, we're going to make this from here to here section 1. And then from here down to here, we're going to make this section 2. Okay? So in order to do that, guys, we have to find the time up. And in order to find the time up, we're going to say our initial velocity in the y is 28.98, which we've already calculated. Our AY is going to be negative 9.8 meters per second squared, because gravity is always pulling downward. And up at the top, we're going to say our final velocity is 0. Okay? So in order to, we're going to find time up, and then we're also going to find this distance from here up to here, and we're going to call that y up. So you'll notice we're looking for t up here and y up. In order to find t up, we're going to use these 4 kinematic variables, which will lead us to choosing this equation, which comes out to be, calculation-wise, 0 equals 28.98 plus negative 9.8 times t up. If we solve for t up, we should come up with negative 28 divided by negative 9.8, which yields a what?
2.9571
seconds. Okay. So that's our time up. And then, guys, if we want to find our distance that we traveled up, we're going to use these 4 kinematic variables, which yields this equation. And we're going to come up with something like this. 0 squared equals 28.98 squared plus 2 times negative 9.8 times y up. And if we solve that, 28.98 squared negative divided by a negative 19.6, and we come up with a y up distance of 42.849 meters. Do I get some verification on that? Okay. All right. So this distance right here is 42.849. Would you guys agree that in order to get this total y, is that going to equal y up plus 35? Because we already have 35 here. Okay. So if we come over here, our y down from the very top is equal to our y up plus 35, and our y up was right here. So what does that give us? 77.849?
Yeah.
Okay. So now, guys, we know we're at the very top of our flight, and we're going to try to find the time down. We know that at the very top of our flight, our velocity is 0 in the y direction. We know our AY is negative 9.8. And we now know our new y down is equal to 77.849. So given those 4 kinematic variables, I believe we would use something like this. Y down equals V naught YT down plus 1/2 AYT down squared. We can plug it in. Our y down is 77.849 equals, this whole term goes to 0, which is really nice. 1/2 negative 9.8 times t down squared. Now, guys, one thing that I've noticed, if we're talking about y down, is that going downward? So we need to make this a what? We need to make that a negative, which also makes this a negative. And so when we take 77.849 divided by, that's a negative, divided by negative 4.9, and then we take the square root. What do we come up with for the time down? 15.887. We got some verification on that?
Machine square root.
Oh, yeah, you have to take the square root of that, I think? That seems like it's too big.
3.986.
Yeah. 3.986 seconds. Okay. So that's the time down. So if we want to find the time total, in order to find the time total, we have to take the time up plus the time down. And our time up was 2.95714 plus 3.986, which gives us a total time of 6 point what? 943 seconds. Okay. Now that's our time total. Okay. So in order to find our distance, we take velocity in the x equals distance in the x divided by the time total. We know our velocity in the x is always 7.7646. 7.7646 equals x all over the total time, which is 6.943. And we multiply those together and we come up with an x distance traveled of
53.91.
Somewhere in there. Okay. Meters. Okay. Verification on that? Okay, so we got verification. So guys, using this method where we went from here up to the top and then from here down to the bottom, we came up with a distance of 53.91. And then you guys can help me out a little bit when we use the other technique where we went from here to here and then from here down. What did we come up with there? 53.904. And guys, just because we've done some rounding, are those pretty comparable as far as answers for how far we went? Okay. So those are two different solutions to figuring out how you shoot a cannon and then figure out the distance traveled down to the ground. So, that in summary, those are pretty multi-step problems, but they're not really that difficult if you break them down into each of the sections and use the kinematic equations, which you guys are getting really proficient at.